What does engineering have to do with human health? We're here at UF's Herbert Wertheim Laboratory for Engineering Excellence to learn more. Harrison, tell us more about who you are and what you do.
Hi, my name is Harrison. I'm a third-year PhD student in the Biomedical Engineering Department, and I'm currently researching how to create tendon models.
What makes tendons so important in the human body?
Right, so tendons are mechanically resilient tissues that connect our muscle to our bone. So anytime we overload our tendons, we run risk of rupturing them or potentially injuring them. So we're trying to figure out how to best maintain our tendons as well as study underlying disease mechanisms.
Tell me more about your research and what you're doing that's different than what's already been studied.
Right, so right now we're trying to come up with a gold standard in vitro model. So we have biomaterial scaffolds, which we are trying to mimic our tendons. And then we also are going to be doing animal models. So both models are going to be comprehensively analyzed to ensure that we have relevance between both our tendons and the tendons that we're going to be creating models of.
What's made studying tendons difficult in the past?
Right, so as I mentioned before, we don't know a lot about how the underlying tendon mechanisms work. So we're trying to figure out what leads to daily maintenance. Whenever we run, we strengthen our tendons. However, if we do not run, we have weak tendons. So there's some healthy maintenance of loading that we need to maintain. Furthermore, whenever we look at the disease, it's not fully clear about what leads to disease and kind of how it progresses. So we're really trying to figure out what are the underlying mechanisms so that we can best figure out how to both maintain our healthy tendons and treat our diseased tendons.
What are some of the common ways that tendons get damaged?
So specifically with tendinopathy is referred to as a failed damage response. So a lot of time runners will be unacclimated to doing high intense activity. They'll go and they'll push their tendons a little bit more than they should, and then they start to have some tissue turnover, which leads to a lesser quality tissue. And we are trying to mimic this in our models that we have.
Why is biomedical engineering so important to human health?
Right, so biomedical engineering is essentially just applying engineering principles to the human body. So broadly, this covers everything from contact lenses to dialysis machines, but more specifically with my research, we're engineering our scaffolds to be able to mimic the aligned and unaligned matrices of healthy and diseased tendon. And then we're subjecting these to strain that would be endured by the human body, and then further strain them and evaluate all the mechanisms underlying that.
If you're interested in learning more about projects like this, stay tuned for further updates from UF's Wertheim Laboratory for Engineering Excellence.